wanted to do a quick video to tell you about doing a problem that's on the homework assignment that has challenged a couple students already. So I thought if I mentioned the challenge, that would be helpful to you. So imagine that you have, three charges lined up. So I'll put one here, I'll put one here, and I'll say I'm interested, I'll call this one charge 1, call this one charge 2, and I'll say I'm interested in their effect on charge 3. And all these charges lie on a line, assume. And this is sort of like the problem when we did with the force acting on the third charge, when the third charge was the vertex of a triangle that lay in between them. But in this case, it's along the line that joins them. Okay, so that's where the third charge lies in this case. So I wanted to show you how we can work with this. I'm going to erase this first. Basically, you can apply the force that each charge acts on charge 3. So I'll say if F23 equals K times Q2 times Q3 divided by R23 squared, where R23 is the separation between charge 2 and 3. And the direction of it, of course, is determined by whether the charges attract or repel. And since I wrote here that charge 3 is negative and charge 2 is positive, they're going to attract. So charge 3 is going to have a negative I hat direction associated with it. Then I also want to find F13. In other words, what's the force that charge 1 acts on charge 3? And so for this one, I do the same thing. I say K times Q1 times Q3 divided by R13 squared, where R13 is the separation between charge 1 and charge 3. And in this case, because both charges are negative, they're both negative, I could say that it's going to be I hat. So what I'm going to get here is some number that relates to this and another number that relates to that. They'll be of opposite sign. This one will be negative, and the other one will be positive. So I have to add them together. And since I didn't put actual distances in here, I can't do this problem, nor did I put charges in. But I can say that I can't say for sure, but if the charges were the same size, I know that this force would be larger. So the result would be probably that this one would dominate, and I'd get a negative I hat result. And so this one would be more negative than this one here was positive. But you have to add these two together to get the result. So hopefully this will help you on the second problem of the homework that is due this weekend if you have questions about it. You might have already figured it out, but if you have questions, this is how you'd approach it. You have to look at the effect of both charge 1 and charge 2 on charge 3, and you have to add those two effects independently.